Greetings, mathematicians. Let's take a look at one of our last lessons. I think we have one more in the unit. Today we are dividing fractions. That's right, my favorite thing in the world, dividing fractions. We're on 31L, 31R. Pause if you need to, otherwise come with me. All right, let me adjust my light. There we go. This auto adjust setting is not quite working. All right, my friends, Unit 3, Lesson 11, dividing fractions. Our objective, I will solve division problems that contain fractions. Really super simple today. Say it with me. I will solve division problems that contain fractions. All right, and in the last lesson, we talked about simple numerical division, a small number divided by a big number. We should know this one pretty easily, but I want to illustrate why it works. 2 divided by 5 will be simply 2 over 5. Let's examine why. I have 2 pieces. I'm going to split them into 5 pieces each. Relatively close. I think I have a total of how many pieces? 10 here. Let me go through and shade 2/5. 1, 2. 1, 2. Purple. Might run out of colors. I hope not. It's got a light shade of pink. Hopefully it's noticeably different than the purple and the red. All right, so I simply have 2/5, 2/5, another 2/5 right here. I'll connect them over here. 2/5. I got 2/5 and 2/5. So I've got one set of 2/5, another set of 2/5, another set of 2/5. That's 1, 2, 3, 4, 5. So I have 2 things divided by 5 different groups. So thus we have 2/5. Let's take a look at another similar problem. Take a moment. Whoops. What do we notice about this aside from my poor drawing? This time we're dividing a whole number by a fraction. So what we're saying is instead of 5 equal parts, we have 4 things and we're dividing it by a third. How do we do that? So in the last lesson, we talked about it being the same as multiplying. So 4 divided by 3 is 4 times, flip it, 3 over 1. Now we've got a much simpler problem. 4 times 3 over 1 is the same as 4 over 1 times 3 over 1. What do we get? 12. So I have 4 things. I'm cutting it into thirds. So each one of these will be third, third, third. Cutting them into thirds. So how many thirds do I have? Third, third, a third. So total I have 3 thirds. This will also be 3 thirds, 3 thirds, 3 thirds. Let's add up our numerators. 3, 6, 9, 12. I'm going to end up with 12 pieces total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So I have a whole number being divided by a third or multiplying each piece by 3. Visual model works. Now let's learn the shortcut. Shortcut. Simple KCF. Stands for keep, change, and then my bubble is too small. Should be flip. Keep, change, flip. So essentially, our first position here, we will keep the number or the fraction as is. So in this case, we'll keep our 4. I can rewrite it as 4 over 1, but I'm keeping it. Next, I can come through my change. I'm going to do the opposite of division. What is the opposite of division? Multiplication. All right. Let me come back through. And then the last one, flip. This one has a specific term. This is called reciprocal. Say that again, reciprocal. All right. And if you get the reciprocal, the numerator and denominator switch positions. Now we have a multiplication problem and we know how to do those. So 4 times 3 is 12. Could be 12 over 1 equal to 12. We could just leave it at 12. All right, so here's the shortcut. You've got the visual on the previous page. Let's try the shortcut. 2/3 divided by 1/4. Let's forget about this drawing here. Let's just use that shortcut. So we're going to keep it. We're going to change it. We're going to flip it. What would that look like rewritten? Keep, change. And this one is the tricky part. It's the reciprocal. It's the flip. 4 over 1. And we simply multiply. 2 times 4 is 8. 3 times 1 is 3. We have a correct answer. Can we keep going? What is the mixed number? How many 3's fit 8? 2. What's the remainder? 2. Keep the denominator, 3. So 2 2/3 or 8/3. This is simply how we use the shortcut. All right, friends, you will find some samples in Think Central that look a lot like this. Thanks for coming in today.